Hello everyone, welcome to another informative video from Surveying and Mapping, also known as SAM. In this video we'll be talking about shapefiles. What are they and how we can use them? Shapefiles were first developed in the early 90s by Esri to use with their new product, ArcView GIS. ArcView was very innovative in that it was Esri's first application that was developed to use a graphical user interface, or GUI. This is common in all applications that we use nowadays. However, back then, this was a big step forward. Prior to that, everything was command line driven, so you had to be a GIS expert in order to access GIS data. ArcView allowed us to be able to create maps, perform edits, perform analysis in a very user-friendly environment. Now, a single shapefile will store either points, lines, or polygons. In addition to that vector data, it also stores attributes that are associated with those features. Here we see a shapefile that's been brought into a map in Esri's ArcGIS Pro product. Here's the shapefile that you can see down here. It's the parcels shapefile, and I know that because it's showing a .shp extension. We'll talk more about file extensions associated with shapefiles a little bit later in the video. But you can see the polygons being displayed in the map. What you don't see, at least initially, is the attributes that are associated with that. So if I right-click here, I can open the associated attribute table. So this is a database table that is tied to the spatial data you see here. So if I go up and I select a parcel here, it highlights or selects the record in the attribute table. So this is additional information about this specific parcel. So I can see things like the area, the perimeter, a parcel inventory number, a parcel ID number, the zoning, and so on. As I create the shapefile, I get to decide what fields or columns are in this attribute table, so that we see the link that happens between the spatial data and the attribute data. Now, because shapefiles have been around for a long time, most applications that have any sort of GIS capability are enabled to be able to read and sometimes write or export shapefiles as well. This includes applications such as Esri's ArcMap and ArcGIS Pro, but it also includes open source applications like QGIS and PostGIS, or applications from other vendors such as Autodesk, which would include Civil 3D and Map 3D, or Bitly, or Intergraph, Leica, Trimble, and the list goes on. Pretty much any of these that have GIS capability are able to make use of shapefiles. And as a result, shapefiles have become the de facto data sharing format between all of these various applications, just because everything can read them, which makes them somewhat versatile. There are limitations that we'll talk about also later in the video. If you're going to use shapefiles, you need to understand the structure. Contrary to what the name would imply, a single shapefile actually consists of multiple files. At a minimum, there are 3 mandatory files that you must have in order to have a working shapefile. These are the SHP, the DBF, and the SHX. The SHP file stores the spatial data, so this is going to be the coordinates that make up the points or the lines or the polygons that are part of the shapefile. The attribute data is stored in the DBF file. So those attributes that I was just showing you, those are coming out of the DBF file. Now, the DBF is based on an old database format called DBase, specifically DBase 4. Now, DBase was originally developed back in the late 70s and continued to evolve into the 80s and early 90s. Now, because of that, there are going to be limitations on what you can do and store within the attribute tables associated with a shapefile, because it's built on that older technology. We'll be talking about those limitations again a little bit later here in the video, so make sure you stay tuned and keep following. Lastly, you have to have an SHX file. This is an index file that links the SHP and the DBF together, so when I do things like you saw just a second ago, when I select in that case, a parcel polygon, it also selects the related row or record in the attribute table, or vice versa. I can select a row or record in the attribute table, and it will also select the associated spatial feature. The SHX is the file that links that together so that happens. Now, there are a lot of other files that can be associated with a shapefile. Here we're looking at a shapefile in Windows File Explorer. So this is what you would see if you weren't looking at it in any sort of GIS application. You can see the files we were just talking about. We have the DBF. We have the SHP. We have the SHX. Those are those three mandatory files, but you can see other files here as well, such as a PRJ or an XML. You'll see SBN, SBX, ATX, IDX, just to name a few. Each of these additional files, though not mandatory, do serve a purpose. For example, the PRJ file identifies the coordinate system or projection that the shapefile is stored in. This could be WGS 84 latitude and longitude. It could be Web Mercator Auxiliary Sphere, which is used by many web applications, including Google Earth or Google Maps. It could be UTM, or your local state plane coordinate system. That information is going to be stored in the PRJ file. Now, there is one caveat to this. In the case of most shapefiles, that's going to be assigned manually. So it's not unusual for that to be assigned incorrectly. I've encountered many shapefiles that I've gotten from other places, other people, that had the coordinate system and projection assigned incorrectly, which meant the PRJ file was wrong. What that means is that when I bring that shapefile in with other GIS data, it will not display in the correct location. It will be shifted and potentially scaled in some form or fashion. The XML file is another good one to have. It stores the metadata associated with the shapefile. If you're not familiar with the term metadata, that means data about your data. So if somebody's taken the time to create the metadata for the shapefile, you should be able to see things like, why does the shapefile exist? How often is it updated? How was it originally created? Are there any restrictions such as copyrights associated with the use of that shapefile? That can all be stored in the metadata. You'll find that a lot of shapefiles don't have metadata. That was a relatively new concept compared to the age of shapefiles, so those will be missing. There are several types of indexes that can exist with a shapefile: a spatial index, an attribute index, a geocoding index. And there are going to be files for each one of those if they exist. The nice thing with shapefiles is that most applications, when you use a shapefile, if they need one of these indexes and it doesn't exist, it will often create those automatically. So if somebody sends you a shapefile and it doesn't have any of those indexes, you still should be okay. It should still work. It may not perform optimally when you do searches and queries and things of that nature, but it'll still display. You can still open the attribute table. You can still select features. And there's going to be others. This is just a small sampling. For example, you may have a CPG file that's a character encoding file that would be associated with it. And again, there'll be multitudes depending on how you use the data. The key to remember, though, is you have to have those three mandatory files: the SHP, the DBF, and the SHX. As long as those exist and they have not been corrupted. And you may ask yourself, well, how can they get corrupted? Well, some of these files can be opened by other applications that are not GIS. For example, a DBF file can be opened in Microsoft Excel. If somebody were to open a DBF that's part of a shapefile and edit it in some way, they delete a record, meaning a row, they delete a column or a field, and then they save that back into the DBF format from Excel, then that's going to break the shapefile because that DBF no longer matches up with the SHP or the SHX. It's important to know that. Don't go trying to edit or work with these files outside of a GIS application. A GIS application like ArcGIS Pro, like QGIS, understand the relationships of these files. And they're going to allow you to work with them in a way that doesn't corrupt them, so they still work. It's important to remember that. Now, several times I've mentioned that shapefiles have limitations. And they do, because they are built on old technology, such as DBase 4 that we've talked about. We have to think back to what computers were like back in the 1990s. I bought my first computer somewhere around 1994. And I remember things like it was DOS based with Windows 3.1.1 running on top of DOS. And it had a 428 megabyte hard drive with 8 megabytes of RAM. Our phones that we use, our smartphones, have more power than that computer had, more storage than that computer had. So it makes sense that any format developed back during that time frame is going to come with strings, right? So what are some of the limits associated with a shapefile? Well, we've already talked about the first one, and it's a vector-only format, so it doesn't store raster at all. So it's going to store those points, lines, or polygons. And it's going to be further restricted in that each shapefile can only store points, or it'll store lines, or it will store polygons. Going back into ArcGIS Pro, we can see this. I've got a folder here called ArcView, and in it I have a bunch of individual shapefiles. And you can see by the icon, this is a point shapefile. This one's a polygon shapefile. This one's a line shapefile. And you can see that continuing on. This is not a shapefile. This is a raster. I know this is a shapefile because in the case of ArcGIS Pro, and the same is true of ArcMap, it's highlighted with green icons. That lets me know I'm talking about shapefiles, and of course the fact it's showing this .shp extension. So unlike other more modern GIS storage formats like Esri's GeoDatabase or even AutoCAD DWG files, those can store multiple entities, whether it's points, lines, or polygons, or in some cases even raster, in a single storage format. Shapefiles only store that single entity. It's either going to be a point shapefile, a line shapefile, or a polygon shapefile. So that's important to note. Also, it's limited in size. Again, thinking back to computers in the mid-90s and their capabilities, they did not have big hard drives. They didn't have a large amount of RAM. And so storage formats like shapefiles reflected that. The maximum size is 2 gigabytes. And that's in any file that's associated with the shapefile. So if the DBF gets to 2 gigabytes and the others haven't, then your shapefile won't store any more information. The same is true if the SHP gets bigger than 2 gigabytes. You're not going to be able to put any more information into the shapefile. Another issue we have is how it deals with null values. Null values are those that are left blank, that shouldn't have any value stored in them. Well, shapefiles don't leave those blank. It's going to insert a 0 where there are null values present. Or I should say, where null values don't exist, right? Because it's blank. That is problematic for a couple of reasons, and it may seem like that shouldn't be an issue, but if you try to go back and try to identify where data may be missing because somebody didn't completely fill out the attributes, there's going to be a 0 into that field, into that value. Well, is that one somebody forgot to fill out? Or is 0 the correct value? How do you sort through that? How do you identify incomplete data? if it's not allowed to be blank or null. So this is an issue that if you work with shapefiles, you need to make sure you're addressing. How do you identify something that somebody hasn't looked at? So maybe instead of putting a 0 there, you go ahead and default to something like 99999 or some other value that would trigger that, depending on what type of field it is. Another limiting factor that really goes back to the operating systems of the time, which were primarily DOS, Windows running on top of DOS, which were 8-bit operating systems. These had limitations that were then imposed on the application and the file formats of the time. One of those is going to be the length of both the file names and, in the case of the attribute table, the field names or the column names. They typically need to be limited to 8 characters. That's as long as they can be. They also must start with a letter and contain no special characters, meaning it can't have spaces, ampersand signs, hashtags, slashes, or dashes. The only special character that is supported is an underscore. Another limitation, specifically looking at the number of fields that can be included in an attribute table associated with a shapefile, is 255. So fields are columns, those columns that are in there. The maximum number in that attribute table is 255. Another restriction you're going to encounter that you don't see in things like geodatabases or Oracle Spatial or SQL Spatial, all of these are other GIS storage formats, is shapefiles don't support rules or behavior natively into the format. So what am I talking about? Well, with more modern formats, I can apply rules to my data so that I can say things like a manhole must be connected to a sewer line, or parcel polygons must not overlap. That helps with my data quality. But I can also look at attribute data and assign things like domains, which are drop-down pick lists, so it limits the value somebody can pick when filling out that field. I can do subtypes, which allow me to create subgroups within my data, which then I can apply different rules to. I can also do things like contingent values or attribute rules that constrain the values associated with that field based on other values, or it calculates the value based on several other fields. Again, to help with data clarity, data accuracy, and data completeness. Shapefiles do not support that as part of the shapefile. It's not to say you can't potentially do other things programmatically that would apply that type of behavior, but it's not going to be native to the storage format itself. So there you have it. That's what a shapefile is. Hopefully you now have a much better understanding of this format and how you can use it best if you choose to use shapefiles as one of your primary GIS storage formats. If you happen to have any questions, please feel free to leave a comment down below or shoot me an email. I'll do my best to respond to it as quickly as possible. Of course, don't forget to give the video a like if you found it to be helpful at all. And also share it with others that you think may benefit from the information here. Also, remember to subscribe to our channel and enable those notifications so you'll be notified when we post new videos up here on the SAM YouTube channel. We really appreciate you watching and thank you for all your support. We'll see you in the next video.